Today I want to veer back to the topic of functions, but we're going to explore a little bit deeper. We're going to talk about default parameters and name parameters. And there are some gotchas about using default parameters that we're going to talk about that'll maybe give us some insight into the way that Python works. We're also going to need to talk about the way that parameter passing in Python differs dramatically from parameter passing in, say, Java. So, to kick us off, we're usually using this trinket book. But I want to blip into a different textbook, one that I've used in the past for fundamentals, although I'm not using it this semester. But I like it. I may go back to it. Rather than make them pay 80 bucks, you can always use a free one. So, functions. We know how to write functions. You have the def keyword, then you have the name of the function, and you have a parameter list. The parameter list is optional. And then you have some statements that are subordinate to the header of the function, a block of code. And of course, functions can call other functions. This is giving an example that would be fun to type, but I don't really think that we need to take the time to do so. Using the turtle, they've made a function that draws a triangle. Right? You pass in the turtle that you want to draw with, the width of the rectangle, the height of the rectangle, did I say triangle? And then it goes ahead and draws it. And then if you want to, you could make another one called draw square. What's the difference between a rectangle and a square? Is that the height and the width are the same. So here they're passing in a turtle. For some reason they've given it a different name, tx rather than t. And they're passing in size. And so when it calls draw a rectangle, they're passing in the turtle. But the height and the width are both being set equal to the same size parameter. Well worth going to this alternate text and researching the subjects that you're curious about from our lectures or from the book. So you can have functions that return values, or you can have functions that don't return values. If a function does not return a value, it still returns a hidden value called none. Let's go ahead and crank open idle because it's more fun to write our own stuff than just stare at the page. So I'm just going to call this March 27. Surprise. Alrighty. Let's make a function that doesn't do anything. Define, I don't know, I'm just going to call it A. And it prints A. And it returns. Alrighty. Let's store the return value of that function in a variable. A was a really bad name for a function. That's just a stupid, but whatever, A123. Okay, so A is equal to the return value of A123. Now let's print it out. Int is not callable. Oh, excuse me, A123. I left off the A there, so if you typed what I did, make sure that you type A123 there. So check it out. It actually did return something. It returned the secret value none. This is different from Java and C++ and stuff like that, where if you define a function as being void, it really doesn't return anything. It doesn't return a value that you can test against, and you can't assign that to anything. But here we could. And you could use that if you wanted to. You can.
So because it doesn't return anything, you actually don't need the return statement.
That's correct. That's correct. If I took that statement out, it would still work and it'll still print none.
That's what I did with my code.
Right. So none is a data value, just like anything else. If you want to, you could do this. B is equal to none. And if you print B out, it's also going to print none. So you may be able to take advantage of that, right? A lot of programmers like to declare their variables up at the top of their code and then use them later. And Python doesn't require you to do that, but if you wanted to, you could do. You know, you could do, don't type this, I'm going to delete it. The cost is equal to none, the total is equal to, whatever. And then later on, you could give those real values, but at least up here at the top, you've given some comments. What does that cost mean? What does that total mean? That way. So that gives you the ability to give, some definitions up there. I don't consider that critical. We're going to go back to the idea of none in just a minute, though. A function can return anything, any kind of data, and it can return more than one piece of data. Let's write another function. Find B, 2, 3, 4, whatever. And it is going to return something. But it's going to return two values. Now, you programmers who've used this language or another one know that you can always return one value from a function, a method, whatever you want to call it. But we're going to, I'm going to make it return names. Joe, Bob. Alrighty. So then do a comma b equals, and then put a function call that does that b2, 3, 4. A comma b is equal to b2, 3, 4, like that. When it's done, a is going to equal Joe, and b is going to equal Bob. Now that's weird in my brain. In other languages, what you would have to do is you would have to store those values in a list or an array in order to get more than one element back out of a function. Well, that lets you do silly things like this. A comma b is equal to b comma a. That's moronic, but it works. That would copy the value of b into a, and that would copy the value of a into b. Or you could have done a comma b is equal to, and then give it, two other names, road, runner. It looks like a list, doesn't it? But it's not a list. You don't have an index value. You can't, access element 0 and get road out of it, and access element 1 and get runner, because it's road is just a single value stored in A, and runner is another value stored in B. What if you want those values to be accessible like that, by index value? Then you better make a list or a tuple out of it. A tuple is an immutable list, one that you can't change. Okay, so I could do this. List is equal to A comma B, and then I could access the elements. I could print out L subscript 0, and it would give me road, and L subscript 1 would give me runner. Now that may be getting a little bit abstract for some of y'all, but we really, really, really need to learn to hammer in on lists. It's like we ought to do it for the next several class periods, lists over and over and over. So that's one way of defining a list, right? Put your braces in there, your brackets, and then you put items in there separated by commas. Usually what you're going to do is you're going to build your lists on the fly. And the way you build your lists on your fly is you declare an empty list. And in Python too, you had to do that in a weird, fun way. forget it. Oh, I saw it. Dadgummit. Okay, forget it. In Python 3, creating an empty list is as easy as doing this. List is equal to that with nothing between them. Then you can start appending items to it. You would ask the user for these values. You would call functions to get them. So l.append, let's copy a into it, which is equal to road at this point, right? Because we said a is equal to road and b is equal to runner. And let's append b to the list. And now if we print the list out, it will say Roadrunner in the list format that we're used to seeing. And it didn't.
You said print B.
Oh, I did print B rather than print the list. And that's why some people pay to have two programmers sitting at one workstation. Okay. Which would drive me up the wall, but as you can see. Okay, so we built a list out of two items by calling .append. There's two concepts in programming, the idea of stacks and the idea of queues. Have I mentioned those yet? A stack is something where you add items on one end of the list and then you remove the items from that list on the same side, like a stack of plates. Put a plate down, put another plate down, put another plate down. Now when I'm ready to take something, I grab the top plate. I grab the next plate. I grab the third plate. Now my stack is empty. Notice that it is first in, last out. That's the first item. Another item. Another item. I take that off. I take that off. This is the last item I take off. So stacks are first in, last out.
And a queue is first in, first out?
Exactly. So stack is a list, essentially. You could do it, you know, with whatever data structure the language supports. Where adds and removes are done on the same end. Then there's queues.
Probably wanted to be a comment, I was going to say.
What'd I do wrong? Oh yeah, comment. Yep. Thanks. So a queue is a list. Okay, I forgot to add the second comment. Stacks are LIFO. Last in, first out. I think I said first in, last out, but the usual way people say it is LIFO. I guess that sounds better than philo. Last in, first out. So queue is a list where adds go on one end and inserts go on the other. Nope, inserts and adds mean the same thing. And removes go on the other. You know, the British call standing, you know, in line to get a movie, they say you're standing on queue or standing in queue. We say you're standing in line. The queue means that people get into it on one side, you know, and they start backing up, but the people actually get into the theater on the other side. So that's first in, first out. Python doesn't have a separate structure for stacks. You just use a list. Other data structures, you can simulate stacks using a list, but they quite often come with their own stack class. And if it comes with a stack class, then the two operations, the adding to it is called a push. I'm going to push an item onto a stack. I don't know, push. And then when you're ready to get an item off the stack, it's called pop. I don't know who made these terms. I pop it off the stack. So those are the two operations in effect on a stack. Push and pop. Now, to satisfy the people who would like to use Python lists as stacks, they did go ahead and implement a pop function. Let's make a little stack. Excuse me. We're going to make it a list, but we're going to treat it like a stack. L is equal to, let's just give some items to it. 12, 13, 14, 15, whatever. And let's pop one of those values off. A is equal to L dot pop. Now let's print A and the list. Right? We had a list that said 12, 13, 14, and 15, but after the pop, it deleted, it removed the item 15 out of the list and returned it so that we can access it. And if we had appends, they would be going on to the end of the list. And then our pops are taking off the list. So we have our data structure where the adds and the removes are happening on the same side. So what if you wanted a queue? Well, instead of doing appends, I guess I would just insert them at position 0. So I'd be inserting things here, and then I'd be popping them off there.
The pop you can put in an index, and it removes any index.
Yeah, which is a total perversion of the idea of a stack,
Yeah.
but whatever. So that is true. You can extract and remove any item from the list. Like say we wanted to pop the first element out. A is equal to L dot pop 0. And let's do that stuff again. Let's print A and then L. And we'll see that the first item was removed from the list. There we did. So it yanked the 12 out of the list, it popped it off, and so our list is short that way. And sometimes you want to do that. You know, if you want to yank data out as you access it, popping is a perfectly great way to do it. What happens if you pop an index value that doesn't exist? It should generate an exception. Somebody test that. Pop out item 5 when we don't have an item 5.
Index error, pop index error.
Yeah. So you could do one of two things. You could use a try except, or you could just check the length of the list. Either way.
If the index variable is less than the length,
Then the length, then you're good to go. Right. This is good, this is good. And then parentheses 0. Yeah, 0 there, and then just print out A comma L again. I like how you do that. I do it too. Put the parentheses and then go back. All right. So just be aware that if you're talking to a Java programmer or something and they're talking about popping, they definitely mean it's taking it from the end of the list. I do not think. Yeah. So it's going up. Yeah, the question is, how did we make this to be a stack? And the answer is, a stack is just a list in this language.
Yeah, it's just a list that you're treating like a stack.
Right. You know, it's like buying a Tide Pod and you could eat it or you could use it to wash your laundry. You know, it's the same Tide Pod. That's a stupid example. So, you know, this is our stack just because we decided to treat it like one. Otherwise, it's a list.
Is Q just something different?
Yeah, we're treating it differently. We're using a pop function, which is a stack concept, but it's still a list.
Okay.
So that is a list. A tuple is an immutable list. I'm going to use capital T for tuple. Let's put some values in here again. 12, 13, 14, 15. How do you define a tuple? With parentheses rather than square braces. The difference between a tuple and a list is that you cannot remove items from a tuple and you cannot change their values. So this would be a syntax error. This will work. If I change the first item of the list to something else, that's great. You can do that as long as the index value is valid, and it is. But if I try to do that, that's an error. Whoops. Yeah. It says tuple object does not support item assignment. That's a long way of saying that it's immutable. You can't change it. But you could get the data out that way. We could print that value, that first value in the tuple, but we can't change it. So I could do print t square brace 0, and it's going to print 12 because that's the first value in the tuple. Now, a slight quirk in my mind every time I teach this and demonstrate it is that since I declare the list with parentheses, I feel like I ought to retrieve them with parentheses. But parentheses have a very, very specific meaning. It's a function call. So the same syntax is used for pulling things out of a list or a tuple. So if you have a tuple, you can't append to it, you can't pop anything, can't change it. Sometimes you may have a piece of data that you want to be like that. You want to pass back something from your function that you are sure that the calling code isn't going to monkey with. Now, right off the top of my head, I can't think of one, but you could do that. Right off the top of my head, I can't ever think when I wanted to use a tuple rather than a list.
Should the T be capitalized?
In the print statement, yeah.
Yeah, that needed to be a capital T, and I'm very sorry about that because I did capitalize that one. That's what I get for not running the code and continuing the lecture. All right, so it printed out the first item in the tuple, just as we expected. Pardon me? Yes, I certainly hope so.
Nope.
Yes, yes indeed. All righty. So your function can return anything. Remember up here when we had a function that returned none? Okay, that's great. A function can return one value, which is commonly how we write them. Right, you're converting temperatures or whatever. You pass in Celsius, it returns a Fahrenheit. It can pass in a series of values separated by comma. Or you could return a list. You could return a tuple. If you start defining your own classes, which we will, you can return one of those. For example, the turtle is a class. We could create a turtle and return that. So any data type that you can manage to create, a function can return one or more of them. And they can return differing data types. I don't necessarily want you to type this. But if I had another function and it returned this, returned a true and a string and a number, that works. And then when you call it, a comma b comma c is equal to c123, then a is equal to a Boolean variable, and b is equal to a string, and c is equal to 1, 2, 3, and you just have to keep track of that in your head, because this is not a type-safe language. It is not a strongly typed language as opposed to all the C languages in Java. All right, there are default parameters. A default parameter is one that you could fill in, but you don't have to. I'm going to write a function called add that takes two numbers and adds them together and returns it. But then we're going to modify it so that you could also add 3 numbers and you could also add 4 numbers. So guess what we're going to do? We're going to type def add. And we do want to provide a parameter list. How about P1 and P2? And then total is equal to P1 plus P2, and then return total. So let's add two numbers and print them out. Just call print, parentheses, add parentheses, and feed it two numbers. Print, add 100 and 200. It should print 300. And there we go. It printed 300 because it did call the add function successfully. And then you think to yourself, I want a function that'll add three numbers. In a type-safe language, you could, quote, overload that function. They would call it a method because it would be attached to a class with a version that takes 3 parameters rather than 2. And then you could overload it again with a version that took 4 arguments. And then when it is compiled, it stitches it all together. But we don't have that. We don't have the ability to overload our functions. But I really do want to be able to pass in 2 or 3 or 4 parameters. Like I want this to work. X is equal to add 1, 2, 3. And I want to be able to do another one. X is equal to, or Y is equal to add 1, 2, and 3, and 4. We're going to have to modify our function. Could we just add P3 and P4? No, that's not going to work. We may as well try. Add 2 more parameters to your add function. Add comma P3, comma P4, and run it and see what you get, which is a whole lot of errors. It'll tell you something like it takes 2 positional arguments, but 3 were given. Or, you know, something along the line of how many positional arguments it takes and how many were given. I haven't added them yet, so when you
actually tells you before you run it that it's missing parameters.
Oh, really?
It has too many parameters. Yeah.
Okay, cool. So I'm going to go back to the add function, and my first attempt at getting this to work, I want to see if that's PyCharm or if that's... See, I just added 2 parameters here. So we should have P1 through P4 in our parameter list. No, mine did not tell me. I want to see yours. Tell me.
So like right here, it's highlighted.
Well,
See how it's highlighted?
okay, that's a
So it
function of
tells
the
you.
editor rather
Yeah.
than the language. That's cool. That's cool.
And if you have too many, then it highlights the arguments past a certain number that you don't need.
That's cool. Okay. So I want this to work. What I'm going to do is I'm going to provide default values for P3 and P4. So this is the line I'm changing again. Heck, we could provide default values for all of them. Be kind of dumb, but we could. P1 is equal to 0, P2 is equal to 0, P3 is equal to 0, and P4 is equal to 0. Now we can call it with no parameters, 1, 2, or 3, or 4 arguments. I'm using the term parameters generically. You know the difference. When you're calling the function, they're called arguments. When you're inside the function, those are the parameters. Okay, so it worked. We passed in, well, I didn't print them out, but
You might
it
want to
compiled
change
it and ran.
your total to be P1 plus P2.
Oh, you're right. You're right. It still is only adding the first 2 values, but I made it so to accept 2 more arguments, but I never added them in. So I had to add support for P3 plus P4 here. So I'm making a little comment there. And And since I'm not printing them out, I don't know if it works. I guess I'll add a print form. Print x comma y. All right, sure enough, 1 plus 2 plus 3 is in fact 6. So that's working. So default parameters are cool. Some other languages allow you to pass in a list of arguments, and it will convert them on the fly to an array so that you can access them like that. I do not believe that Python does that, an array being their version of a list. The difference between an array and a list is that an array is a fixed length. Once you say I want a list of 5 items, too bad if you want to append to it. Too bad if you want to delete one from it. It's always going to be 5 until you reallocate it. So when you hit another programming language that uses arrays, you'll keep that in the back of your mind. Anybody get syntax errors?
I'll go ahead and run it.
Oh, that's because I changed it from A to A, 1, 2, 3, 4. So just go add 1, 2, 3, 4 after the definition there. Not inside the parentheses, but like that. Like that. Just because I had to match that. Let's go ahead. Okay. None was the expected. And if and you want, you can access the parameters. Let me make sure I'm not speaking with forked tongue here. Okay. I do believe this is going to work. We're going to find out. We want a function where we could pass in somebody's name and their address and their phone number, and if those things are provided, great. But if anything is missing, or if we want it so that you can pass them in any order, and you can leave some out. So I'm going to write a function called pad that takes 3 arguments. Pad standing for print address. It's going to take someone's name. It's going to take someone's address, which I'm abbreviating ADDR, and their phone number, NUM. But let's give some default values for these. Let's make them all empty, set to empty strings. Maybe not the most elegant solution, but for now it'll work. Or heck, let's just put default in for each one so that we could watch them get filled in. Except I can't type. Okay. So what I'm doing is I'm saying name is equal to default, address is equal to default, and num is equal to default. So print, let's use some formatting. %20s, 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 end quote, percent, and then we have to pass in a tuple of data to pass in, the name, the address, and the number. Just make sure you get your number of opening and closing parentheses correct. Now these are all strings, so when I pass in a phone number, I'm going to pass it in as a string. So I'm going to stop indenting and do pad. My name is Joe. So pad parentheses quote Joe end quote comma, and my address is 123 South Main. End quote comma, and my phone number is 747-7777. I have filled in all three arguments, have I not? So I'm not seeing those words default anywhere. What if I call pad, which is 2 pieces of data? I don't know their address. So I'm going to say Bob, and I'm going to give him a phone number. 621-2121. It's not going to look right. I forgot my quote. So if I wanted this column to be my phone number and this one to be my address, you can tell what's happening, right? Since I didn't fill in the third parameter, it got a default value, and whatever I provided, the function doesn't know that that's an address. All it knows is that it's the second argument that was passed in. We'd like to be able to specify, though, that that is a phone number. We'd also like to be able to provide them in any order, but this is going to be good enough. Sam, comma, and the number is equal to 555-1212. Then print it out. The address column is now going to say default. It's going to behave more like what we want. This is what's known as a named argument. C# supports it. I do not believe that C++ and Java do, and I like it.
I don't think Java does. Last time I used it.
All right, so it worked, right? We were able, I'll bring the code back. We were able to pass in a phone number and a name, and it left the address out. It would look better if we removed those, defaults and just made them empty strings, right? But I just wanted you to see them. Let's call it once more. Pad with the address equal to 42 West Street and the name equal to, now I've already used Sam, Sue, and I'm not going to even pass in an address. Suddenly it occurs to me to pass in 2 arguments with the same name. So somebody tests it out. Call pad and specify name is equal to, value 1, and then name is equal to value 2. All right, so you see what it did? We were able to pass in the name as Sue and the address as 42 West, even though they were in the wrong order.
It gives an error if you put name twice.
Okay, that's comforting. So, do you have to use named addresses when you write your functions? Or, excuse me, named arguments? No, absolutely not. But you'll see stuff like that, like in the Turtle library, when you're going to when you're going to call a function and you want to optionally set a color. Don't type this, but draw, a circle, and if I want to specify a value, I could say that its color is, red, and that its size is 3. That's what it's doing, is we're creating named arguments, and the draw function has been created such that you don't have to pass them in. I'm sure that they have default arguments of nothing, And, you know, you can put them in any order that you want. You do not. What is the advantage of that? What if I had to pass them in without named parameters? That's what the function would look, and like I said, don't type this in. That's what the function would look like if it was order dependent. And what if I wanted to leave out the color? What if I wanted the ability to leave out the color? Well, I can't take that out. It's not going to give a default value for the color because it goes by place, right? That's the first argument, and that's the second argument. So it's nice to be able to do it like that. If you have functions which are going to take different numbers of optional arguments to fill in your parameter list. Now really, most of the time I don't want to set them to a word like default unless I'm just trying to chase out an error. And I really don't want to set it equal to an empty space. What would be appropriate is to set the name to none, the address to none, and the number equal to none, and then check at runtime to see if name was equal to none, so that I would know. And I could behave differently based on whether it was none or not. You know, I might not print it. Okay, here is a huge difference between this language and other languages. Other languages do something that's, or at least by default, C++ lets you mess with this. You can pass in data, and it's known as pass in by reference. And in this one, and then in other languages, you can do pass by copy. If you pass by copy, it copies the value of the variable into the argument. If you pass by reference, it actually is the same variable inside the function. Now that sounds nebulous. So we're going to give an example, and I want you to be warned that this is absolutely not true in a lot of languages, what we're about to do, because they do pass by value, pass by copy. So let's write a function called change. And it's going to take a variable a, and it's going to say a is equal to 13. Whatever. I forgot to add the def in front of it, so make sure it says def change. Def space change. Now let's call it. Let's give a default value to a, because you have to have a variable before you can call it, right? Whatever. I'm just going to set it equal to none. And then I'm going to change a. By the time I get out of it, is it still going to equal none, or is it going to have been changed to 13? There's an intuitive answer, perhaps, if you haven't done languages that do the other. So let's print a and see if it prints out 13. So these are our new lines of code. We have written a function, takes an argument, assigns the value of 13 to that parameter. So we're going to call that function, we're passing in a variable, and we're curious about whether it's still equal to none or if it picks up that 13.
Still none.
Well, then I told a big fat lie. Okay, I've added. Oh,
Yeah, you have the draw function.
delete that. Let me take 17 seconds to see where I got my horribly wrong information from. All right, I didn't save that page. This is actually good news. Why is it good news? A is a local variable, and making changes to A should not affect what it is down here. You may think it should, and in some languages you can tell the language that no, you really want it to do that.
You could set it up so that it would change the value if before you made change you initialized a as a variable for the whole function, and then you just assign
Exactly.
it to a
You can make
function.
it a global variable.
Yeah,
Let's
yeah.
play with that. I'm going to move this a is equal to none and push it up here. Now I'm expecting it to actually behave the same way because of one
Yeah.
change.
Yeah.
What you want to do in order to get that to work
Get rid of the parameter.
is, well, that would work, but global a. That says that a is a global variable. Inside this function, yeah. Let's get rid of that a. Let's take your suggestion, make sure that it behaves the way that I'm expecting. Okay, fine. Take that out. All right, guys, I've made a lot of changes. I'm sorry. I moved that up there. I took the parameter out from the change,
Now it looks like you have to add global.
and then I also removed it from the call, from the argument list. And when it runs, it's still equal to none. This global variable, or what you would think would be a global variable in other languages, is not quite a global variable. When you're inside change, you could change it, but it doesn't change the global reference to it. It's treating this like it's a local variable. It's saying, hey, I got a local variable named 13, and I'm going to add some values to it, subtract it, or whatever, but it doesn't change this variable. And in some programming languages, the area in which a variable can be accessed is called scope. But what if you want to change that one? You can add the word global like this. You can say, whoops, you better not tab it like I did. You can say a is a global variable. So if I assign it a new value, I mean it.
If you type in return before you say you didn't type in global and you typed in return, would it return a?
I could return the value of a so that we could use it.
Okay.
And that's a great way to do it. If you're going to change something, go ahead and return it rather than hoping that you can get it to work like this. This is kind of a lame way of getting it to work. But you can define global variables. And you'll see a lot of code examples, don't type this, where you go, okay, turtle is equal to new turtle, and you create a turtle, and then they declare their, draw functions. This is how I do it actually, and so then I use t.forward or whatever, whatever, like that. It makes it look like t is a global variable, and it did pick up the value of t. I totally messed this up, but you're getting the idea. But you can't change t. And that's because the t object stays the same. It's got data in it with data values, which you can change it, but then we're getting into the difference between a class, an object, and a variable. So I'm going to stop talking about that. All right, time to add a few notes to hammer in what we've done. I know I already defined what a stack was. Yeah, right there in my notes. How to define an empty list? Just empty braces. How to add to a list? L.append. How to remove that last item from the list to treat it like a stack? Pop.
And pop returns the value that it removes.
Right, it returns whatever is at the end of the stack, or blows up if the stack is empty.
Or whichever index is specified.
Right, and you can specify a value as your argument to pop, and it will remove and return that value instead. Other things you can do with lists is you can, delete an item by its value. I hope it's removed. I'm not gonna go into that. So like if the item Bob was in the list, then it would remove it. But it blows up if it's not in there. So you would want to rewrite this as if Bob is in the list, then remove it. Or you'd put a try except around it. All right, so that's a little bit about lists that I want us to remember. A tuple is an immutable list. Meaning you cannot append, delete, or modify the values, reassign the values. You can use the global keyword to let your function change a value that was defined above the function definition. I want to try something. What if you do it in the wrong order? Name is equal to Joe. Define whatever, F123. And then global variable, but I'm going to move that definition of name below it. So I'm going to move that down here. And then I'm going to call F123 and I'm going to print out name. Does this work, or is that going to be a syntax error? It actually worked. Okay. The reason that worked, when I say you have to define your variable before the function, that's not strictly true. It's convenient to look at it. That's the way that other programmers and other languages think of global variables. You define all your variables up at the top before all your functions. But in this language, you just have to have the variable defined before you call the function. Right? So you could create the variable here and then call the function, and then it goes here and it goes, oh, I recognize the name because you created it already before you invoked me. If you're going to use global variables, put them up at the top. Don't mix them in like that. That was an experiment. In fact, I may delete that. I believe I will. I'm going to delete all of those lines, and if you typed them in, I apologize. Okay. So use the global keyword. So like A is equal to 12, and then define, my function. And I have to do global A, and then I can change the value of it in here. If I did not have that line, it would not change the global value. And something really bugs me about that, and I haven't figured out what yet. Okay, so the global keyword specifies which scope you're operating in. But what I want to know is, if I didn't do that, and I still printed A out before I changed it, it would say that A was equal to 12. It's just a value that doesn't matter if you change it. Okay. So then if you called fun and printed it out, it would print 10 because it's a global variable. If I left this line off, it would print 12 because although we're trying to change it here, it did not take effect. Default parameters. The example, define your function. A is equal to 0, B is equal to 1, C is equal to 2, whatever. And those are values that you can use. Print, A comma B comma C. And so if you call fun with no values, it's going to print 1, 2, 3. If you call fun with one value, it's going to print 100. Why did I say 1, 2, 3? It's going to print 0, 1, and 2 because the default values take control. If you call it with 1, this fills in the first parameter, but it's still going to print out 1 and 2 after that. If you call it with 2 arguments, you know what it's going to do. It's going to print 100, 200, and then print out the value of the third default argument. And then 100, 200, 300, it would print out 100, 200, 300. And what's the syntax if I wanted to fill them in reverse order? If I wanted to do fun 7, 6, 5, but I wanted it to print out 5, 6, 7, I could use argument names to specify which one. So what am I going to put in front of the 7 to get it to work? Yes, I'm going to fill in the name of the argument, excuse me, parameter. And there we go. And I wouldn't necessarily have to do that because it is the middle one, but I'm going to do that anyways. And then A is equal to 5. And so that would print out 5, 6, 7. Because we're giving the names, we're specifying the order in which they get filled in. One thing to note about default parameters is that once you start, you have to keep providing them. What do I mean by that? If I define a function like this, A is equal to 0, B comma C, thinking, oh, I'm going to let them skip the first parameter, that doesn't work. Because if you called it like this, or like this, how does it know which one to fill in? Right?
Yeah, it would put 8 in A, 9 in B, and then give you an error because there's no value for C.
Exactly. And it actually would not even compile. But if it did, that would be what it would do. Is 8, would, because it's positional, because we didn't give any argument names. 9 would fill in that one, and we don't have enough to fill it in. So once you assign a default value, you have to give the rest of the parameters default values as
Or
well.
at least start assigning default values from the last one.
Right, you do it at the last one and then keep working back. You can't mix them like that. You can't suddenly start providing them and then stop providing them. So cannot do this once you declare a default value for one parameter. All subsequent parameters have to have default values. So here was an example of using the default parameters, and then I skipped topics. This is using named arguments. So I'm going to go back and put a comment here. I know that some of y'all type in the notes as I do. When I'm doing it in Notepad, you know that I upload them, but I also know that lots of people like to take notes to burn it into their brain. And we mentioned it, but I'm going to put it in our notes. If a function doesn't return a value, it returns none, which you can check for if you want. And you can use that value for your own purposes. Alrighty, I'm going to go off the rails for one more topic, and then we're going to upload this stuff. You have to be careful with default parameters. So I'm going to define a function called Pika, like Pikachu, for whatever reason. And it's going to have a list. And it's going to take a value that it adds to that list. And then return that. So we have a list. It's an empty list. And then we're going to append the value P to it. Excuse me, V. Make sure I'm doing this right. Our valuable time. Screw that up. Yeah. And then we're going to return our list so that we can play with it. That avoids having to worry about whether it's being passed by reference. Never a bad idea. So you could, you could do this. I'm going to start using other letters for my lists. L1 is equal to Pika, and I want to add the number 100 to my list. Great. Let's print L1. How do we know that this is going to work? Because we have a default value for the list. It's an empty. Now let's make a different list and append a different value to it. L2 is equal to pica,
Oh, curve.
and I'm going to pass in 200 to it. And then let's just print them both out. Print L2,
Put pike instead of pica.
pike. Alrighty. What did I do there? Alright. So take a look at what's happening here. When it runs, this prints out 100, which is what you would expect. I'm going to get up and I'm going to point at the board in a minute. But this prints out 100, 200. Why do these not function the same? This is acting like it's appending the value that you specified to the same list, right? But we didn't pass in L1 here. It's supposed to be still using this default value to create an empty list.
Does the function save the value of the list not?
What happens is that at definition time, it runs through and it gives L a default value of an empty list. So this is a variable that it keeps tucked away in its brain. Oh, I have L and it's a default list. And if you never change it by not calling, by not giving it a new default value, it keeps using the same list over and over. Which is weird. No other language does it this way that I know. It's okay if you don't get this, but I know some of y'all do. So what's happening is that at runtime, when the function is declared, whatever value is being provided as a default is given to that parameter. And if you don't ever override it, it keeps that value. Which is great if it's just a variable, right? You know, p is equal to 3. It's no problem to keep it that. But if you make it a list, it's not good at all. You would change that to look like this. I'm going to call it Pika2. And then you pass in v, but you give it a default value of none. And then you check that. If v is equal to none, we need to make a new list. And then we can do v.append. Excuse me, that was supposed to be an L. L is equal to none. If L is equal to none, then L is equal to a new list, and then you could append L.append. You could pass that value v in and return L. That's a safe way of doing it. Short story is never use a list as a default parameter. Work around it. Yes, it does. That would be an error. And I'm not going to run it and test it. I need to make the Dropbox because we are about out of time. All right. So if you read the book, you'll get a basic understanding of functions and passing in arguments to fill in variables, and we went deeper. Wrong. And I'm serious. If you want a different picture here for our script programming thing, email me a picture. It'll be kind of fun. So this will be assignment H. All right, if you refresh your Dropbox, you'll see the new one. And although we had a break in the due dates for spring break, stuff's coming due again. Actually, we had a whole
Told me
bunch that was
yesterday.
due yesterday. I didn't quite mean to make y'all work over break. I'll be
I
flexible.
thought you specifically intended to make us work over break.
I apologize for that. Well, y'all are ahead of the game. If you wind up being a little late on these, I deeply appreciate the effort that you put in doing it over the break. I'll go back and give you extra credit for making the deadline, but if you didn't, I'm not going to count off for it. You know, as long as you get it done like within a week. Okay, guys, I'll see y'all next week.
Assignments.
Need the code?
When he says Dropbox, he means assignments.